Okay, so why all this foam space? For one, it acts as a really nice passive shielding from micrometeorites, major meteorites, gas lost to space, radiation, gives a nice surface to put the solar panels on the very top, just completely flat. As the sun hits the planet, it's as efficient as it's going to get. You just get all of it. And down below that, you can have the satellites be the roof, and just anytime you don't have enough roof, you just raise the roof. You just jack the whole thing up and put foam in between. Just keep going up. And you build a structural containment for the atmosphere of Mars. You don't blow up the poles. You don't seed it with algae and weight. You don't, fuck that. You just build it. You encapsulate it in massive foam. And what do you do with that space inside? Well, you fill it with the living space of the creatures that survive with a lot less protection, like your crops, corn, bamboo, coconut, chocolate, coffee, cotton, hemp seed, hemp medicines, pine resins, pine trees, wood, fiber, resins, esters, gases, gas exchange, turning a Martian CO2 into structural and food materials and chemistry, resins and oils and fuels and stuff, glues, paints, all kinds of stuff. And this can be produced from space-age ethnobotany, the science of how humans can use plants in space. Lettuce doesn't require gravity. That's Astroponics 101. First science experiment by a student of astrobotany. Astroponics is how do you grow lettuce in microgravity. They did it. It was one of the very first things. And they ate the leaf of lettuce. And it's very small scale. And it takes a whole lot to get that to happen. And now what you really want to do is you want to expand the living tar out of that idea. How do you make a whole lot of lettuce space? And everything else space. Grapes. Grapes would be great. Bring up grape seed. They're very small. Little paper packets in frozen quick locky boxes. And you pop them boxes open and you attach them into structures inside those equilateral triangular struts in microgravity. And you pump heavily moistened air through the whole pathway, at times condensing it so that you can revaporize it with sprayers. You run all the air through a centrifuge that pulls out all the water, and then it can pump it, because it pumps it from the centrifuge into the static lines in the microgravity area, and pumps the water into sprayers to spot spray what you want. The rest is all picked up by section lines that draw the air along a course and suck it back to the other side and spew it out again, or cycle it through, or just push it through. Different ways you can do it. Now, in areas where people have to live, you build a different kind of centrifuge on Mars than you do in space. You have to build a gondola style to come up to 1G on the surface of Mars. But from orbit, you can run all kinds of stuff. You could have a lot of the surface just robotic, just doing stuff like mining and whatever. And the people that operate most of the machinery are up in orbit in a centrifuge that feels like they're on flat, steady ground. And as long as they don't look out the window, they don't get too dizzy. They can have a flat screen that gives a static image of a section of the wheel that they can rotate around and look at. That's a live capture image. Or they can set it so they can see it as it actually is, with stuff whizzing by. That way they'd be able to see other centrifuges, perhaps nearby. You do all kinds of things. Now, in the microgravity foam areas, you can grow a wide range of plants and animals. In space, you can put the animals and fish and things in centrifuges, and the rest you can build pumping the moist air around with compressor fans at segments, pushing it around bends and stuff. Or suction that pulls water from near plants while spraying the water on the plants. And most of the water goes across the plant and into the funnel again and into the next part of the system. You run that nutrient water across all those plants, and a lot of them will grow just fine. And those that require centrifugal force as a replacement to gravity, you can adapt them to growing in centrifuges that have a variable rate of G-force. You can go from 0 to 1. You can slow your centrifuge all the way down for harvesting. Doesn't matter. The plants are basically harvested. So you stop the rotation and you slowly rotate it past a processing section, and it just does it. That'd be one way to do it. In space, that would work really well. During harvest time, you would have to adjust drive centrifuges, large centrifuges that do industrial stuff, big living space or workspace centrifuges, adjust their rate slightly in order to maintain equilibrium, anti-rotation, sympathetic motion conditions across the ship, across the foam. And the foam will take up a bunch of vibration. It totally will, with that linear compression, end rotation, and bending mounted. Okay, so bamboo is an option that has a lot of promise because it grows very fast, can grow very dense, has long structural fibers that are really, the science is out. We can definitely use them to make engineered materials. And one way to do that is ship the type of bamboos that you want to Mars and get them growing in the microgravity foam and cause the containers either to rotate against that artificial wet wind or do other factors to shake and bend that bamboo all the time, just like other plants, in order to stiffen itself. And it'll grow towards light just great. You just put the lights wherever you want. It'll grow towards it, whatever fits. And your harvesters can come in, take up that bamboo, run it to the plant. No train. We're doing good. Okay. This is actually, as long as you watch for the train, is the safest way to go from back and forth. It's 8 minutes 31. So with the vast majority of the foam actually being essentially ag production, largely robotic, with small crews and tour pathways that you can go through and hang out and check out the cool stuff and watch it all happen and even be a part of it. And you know, like the people who come in, they're buyers, they can inspect stuff, how it's growing, everything, look at records, make deals, all that kind of stuff. Tourists, visitors, family that come, it's really easy to make that look really cool. There's lots of ways you can build pathways through all that stuff that are shielded off, heavy plexiglass or glass panels that can be made right there on Mars. And then they're walking through essentially a sealed tunnel, and they got all the wind and the water and the plants moving around and stuff, and the changing of the light to match growth patterns that you want, and even centrifuges for spinning fish and chicken and other animals that don't need that same diameter that humans might, or the same speed. Chickens might be great at 2/3 G with 20 foot of diameter. Who knew, right? So you make a 30 foot diameter, really long, 2/3 G of rotation, fill it full of chickens, and run air through it, right? And have it seeded with plants that the chickens like to eat, along with crickets, right? Or you let them fly around. I don't know. They might actually really dig microgravity. Chickens could fly. They really could. It'd be really interesting to see a chicken react to 2/3 G, full air compression. That ratio between their muscle strength and the density of the air versus the deceleration factor that is gravity. You add all that up, and chicken might be just buoyant, float, fly inside the foam, go where they want. You could have all kinds of birds. You got turkeys, geese, ducks. They may learn to travel really well in those environments. You might try bats. In 2/3 G or microgravity with wind-blown air, especially in microgravity, certain flying animals might do just absolutely well, or amphibious animals like frogs may do really well. A frog hits a blob of water coming along and gets stuck inside of it. He's natural to swim out of this. In microgravity, it's not a problem. Human, not so good. Can, but problematic. So, how do you bring frogs to Mars? Why do you bring frogs to Mars? Why do you bring crickets to Mars? Why do you bring chickens to Mars? How will you bring chickens and crickets and frogs and turtles and coconut to Mars? And what about the bees? Would you like some honey? Wouldn't that be nice? Bees pollinate for you. They might do amazingly well in 2/3 G. And they might adjust after a couple of generations to the electrical fields that they experience inside the foam and do just fine as well, especially if you bring in different species. You could do that in a space-based one if you're worried about what kind of critters you're letting loose in what kind of part of your environment. Okay. It's Darren Marchant, American Nomad News.